In this question, we've been told that there's a uniform ladder AB of length 2a and of mass m. That uniform ladder is resting with the end A on rough horizontal ground and the end B against a smooth vertical wall. The ladder is inclined at an angle theta to the ground. When a child of mass 2m is standing on a ladder at B, the ladder is about to slip. Given that the coefficient of friction between the ladder and the ground is 5/12, find the value of theta. Okay, as always, I'm going to do my own diagram. There are things on the original that I don't want to be there, and there's a lot more annotation that I want to do. We have a ladder. It's in contact with the ground and the wall. There are two reaction forces. We have the weight of the ladder, the uniform ladder, as mg. Reaction forces, as usual, m and s. The ground is rough, so we're going to have friction mu r. We're told that a child of mass 2m is standing right at the top of the ladder at point B, so I'm going to model 2mg, and the angle of incline is theta. I do actually know the value of mu. It's 5/12. Now that my diagram's ready, I can resolve and take moments and try and solve for the unknown angle. Okay, resolving vertically first. R is going to equal 2mg plus mg. It's going to be 3mg. Resolving horizontally, there are only two forces here. S equals mu r. But I know what mu is. I also know what r is. So 5/12 multiplied by 3mg gets us 5/4 mg. This is a uniform ladder, so actually the distance from A to mg is A, and the distance from mg to 2mg is also A. Now, I should be taking moments around A. For each of the forces that do not pass through A, I'm going to decide whether it's moving clockwise or anti-clockwise. And I'm going to start with the anti-clockwise moments. The moments are going to come from A cosine theta multiplied by mg plus 2A cosine theta multiplied by 2mg, and that's going to equal 2A sine theta multiplied by s. The perpendicular distance in each of these cases was A cosine theta, 2A cosine theta, and 2A sine theta. Perpendicular distance times the force. That's how we generate a moment. Okay, let's expand and simplify and see what we get. So AMG cosine theta plus 4AMG cosine theta equals to 2A sine theta multiplied by s. But we know what s is. So this is 2 times 5/4, which is 5/2. So 5/2 AMG sine theta. I'm going to simplify once more, and then I'm going to try and combine the trig values into one. So I have 5AMG cosine theta, 5/2 AMG sine theta. I can make tan theta by using sine theta over cosine theta. So both coefficients are going to be divided on the left-hand side. So I have 5AMG over 5/2 AMG. That's going to equal tan theta. That means that tan theta equals 2. And we're almost there. If tan theta equals 2, theta is the inverse tan of 2, which is 63.4 degrees.